All right, hey guys, I'm so sorry you're struggling. I know the linear and angular speed can be a little bit weird. So I'm just going to go through some of these problems. Your problems are going to probably look a little bit different because you'll have different numbers, but I just kind of want to just go through them and help you kind of see how to do this. So I'm starting with number 6. So let's see what we have here. So when Brett and Will ride the carousel, Brett always selects the horse on the outside, real life here, people, whereas Will prefers the row closest to the center. So here are a couple things we know, right? So we have this carousel, and these rows are 20 feet 2 inches and 14 feet 2 inches from the center respectively. The angular speed of the carousel is 2.6 revolutions per minute. What is the difference in miles per hour and the linear speed of Brett? Okay, so we have two things going on. So this is number 6. Maybe. Whoops. Sorry about that. So maybe not. There we go. Okay, so we have a couple things going on. So first, so what do we know? We know that linear speed, right, is S over T. And then we know that angular speed, which is that omega, right, is theta over T. Okay. And then we also found out that the linear speed is given by R times omega, right? So those are the three, and I'm going to give you those 3 equations on the test. I won't tell you what the variables stand for, but you'll be given those equations. So we have 2 things going on here. We want to know what is the difference in miles per hour and the linear speed of Brett and Will. So let's talk about Brett. What's going on here, Brett? Let's see what Brett's doing. So we're on this carousel, right? We're looking at it from the top, let's say. Oh, wow, that was pretty good. And here's Brett. I think he's on the inside, right? Oh, no, outside. Okay, so that's Brett is on the outside. Here's Brett. Here's Will. I'm not going to draw people for you. And I want to, if I can figure out, because they give us revolutions per minute. And so if I can figure out the radius and I can figure out what my omega here is, then I'll be able to find the linear speed of each one. And then it just wants to know what that difference is in miles per hour. So let's look at Brett. So Brett, and don't worry about the miles per hour right now. Let's just worry about finding that linear speed first, and then we'll worry about getting into miles per hour. So these rows are 20 feet 2 inches. So Brett is 20 feet 2 inches. So I'm going to go ahead and put this all into inches. So to get 20 feet into inches, so I have 20 feet, right? We know that there are 12 inches in 1 foot. And then we'll add that 2 inches to that. So what is the radius that Brett is at? Well, 20 times 12, I could probably do that in my head, 480. Yeah, I don't know. Today's been a day, so already. So that's 200. So Brett's at 242 inches, right? And what do we know? So let's look up here from the center respectively. And what is Will? Will is the row closest to center. So Will in this case, right, it's R. His R is just going to be 14 feet 2 inches. So again, that's going to be 14 feet over 1 times 12 inches per foot, and then plus 2 inches. Okay, so what is the radius for Will? 170 inches. All right, so let's figure out what's happening with, whoa, sorry about that. Oh my goodness, sorry about that. Let me fix that really quick. Let's see what's happening with their linear speed. So now that I have their R, we got to figure out what we mean. And I apologize if I was not clear. I probably should have done another example for you about this revolutions per minute. So let's talk about this revolutions per minute. The angular speed of the carousel is 2.6 revolutions per minute. So what do we know then? We know then that omega is 2.6. Let's just write this down. Revolutions per 1 minute. Okay, so what I need to figure out, remember what omega is, it's the distance in radians, or it's that angle that they go through over time. Well, think about how many radians do you go through in 1 revolution? 2 pi. Right? That's 360 degrees in 1 revolution. So that's the key right there. And maybe that's why some of you are struggling with these, is if it gives you like revolutions per time, that might do it to you. And I'm sorry if I wasn't making that clear. So 2 times 2.6, we'll just leave it in terms of pi for right now. If you notice, then my angular speed is 5.2 radians per minute. And now I think we're going to be pretty close to being good to go. Oh, trying to give myself some more room here. That is not succeeding very well. So let's look at what we have. So V, right, is going to be R times, so I'm going to do V sub B for Brett. That's going to be his linear speed for me. So Brett's R is 242 inches times that 5.2. Oh, I see it, pi. 5.2 pi per minute. Okay, so I'm gonna go ahead and multiply that out with the pi, 5.2 times pi. And so what we get is we get 3,953.38 inches per minute. Okay, inches per minute. And now the fun part, well, I know that was pretty fun, but the fun part is we need to change that into miles per hour, right? So let's actually leave it like this. I'm going to do the miles per hour at the end because I don't really want to change two of them into miles per hour. So this is for Brett. That's my linear speed, right? Linear, and I just use this equation right here is my radius times. So there's my radius and there's my angular speed. Okay, now let's look at Will. Oh, sorry. Okay, so Will's linear speed is going to be, what is the radius for Will? 170 inches over 1 times also the 5.2 pi per minute. Okay, so 170 times 5.2 times pi. We're going to get his linear speed is 2,777. What did they ask you to round to here? Integer or decimal, rounded to 2 decimal places. You know, if I'm gonna be changing this to miles per hour, so I'm actually gonna go out a little bit further. So I'm gonna do 168. Okay, and here this was 0.380, so I think we're gonna be all right with that. Now this is inches per minute, and let's take the difference of those, and then we will. So I'm gonna take the difference of those. Let me get myself some room here. And then I'm going to convert it to miles per hour. And hopefully this will clear up some of this stuff for you. Okay, so if I take the difference of those, I'm going to do the 3953.38 minus, and you could get an exact value of this if you'd put it all into your calculator at once. So the difference then, so this was V sub W. So let's call my answer just V for my linear velocity. Is 1,176.212 inches per minute. And now let's talk about how to change that to miles per hour. So what I do know is I know that I'm going to get to feet first. So in 1 foot, there are 12 inches. And then I know that in 1 mile, there's 5,280 feet. Okay, and then so that, if you notice, we'll get rid of my inches, that'll get rid of my feet, so I'll have miles, and now I need to go in hours. So there's 60, I want the hours on the bottom, so there's 60 minute per 1 hour, and my minutes will cancel there. So what's the difference in their linear speed? 76.212 divided by 12, divided by 5280, and then times 60. So I get 1.1138 miles per hour. And some of my rounding might be off there. I'm intrigued, so let me try it here. If they don't like that, if I'm pretty close, you can email me and I'll just, I'll give it to you. Oh, nice work. See, that's the best part about this is when you answer the question right. If you're having a bad day, just go answer a question right, you know? Well, maybe that's not the best part ever. All right, so I hope that helps. Let's look at the next problem. Okay, so let's look at this one. So the planet Mercury has a radius of 1,500 miles and rotates 1 revolution every 1,400 hours. What is the linear speed of a point on its equator in miles per hour? So this is number 7. Okay, so we want linear speed, right? Linear speed is my radius times my angular speed. And how do I know I'm going to use this instead of S over T? Because it gives me revolutions, and revolutions implies that we have the angles that we're going through in an amount of time. And so let's look at what we have. So we know that Mercury has a radius of 1,500 miles. And then when they tell us here it rotates 1 revolution every 1400 hours, that's angular speed, because that's telling us how quickly we're turning, basically, right, over time. But let's look at how we can make that maybe more useful for us. So we have the 1 revolution every 1400 hours. So I'm going to actually write that 1 revolution per 1400 hours. Okay, so 1 revolution per 1400 hours. How many radians do I know are in 1 revolution? There are 2 pi radians in 1 revolution. So that's the key right there when they give you revolution for an amount of time, is to remember that there are 2 pi radians in 1 revolution. Okay, and so what would that be? That'd be pi over, I can do this, 700 hour. That's kind of a weird way to put it, but now you're going to be set, right? So in miles per hour, so my linear speed then is going to be that 1500 miles times pi over 700 per hour, and then just figure out what that is. Okay, I hope that helps. Let's look at the next one. So this one, a rider in a road bike race had an average linear speed of 40.616 kilometers per hour. The wheel of his bicycle had a diameter of 66 centimeters. What is his angular speed in revolutions per hour? So again, let's take what we know. Oh, metric system, which makes so much more sense, but I still don't like it, even though it makes more sense. All right, so what do we know? We have an average linear speed. So we know V, which is R times omega. So what do I know in this case? I know that V is that 40.616 kilometers per hour, okay? And now I need to know my radius, but look at what they've given me. They've given me diameter, so I have a little bit of work to do to find my radius. So if my diameter is 66 centimeters, okay, then I know my radius is half of that. That's 33 centimeters. However, notice we're in kilometers per hour, and we want revolutions per hour eventually. So I'm going to need to change the centimeters to kilometers. So let's see how we can do that. So 33 centimeters. And you guys, I'm going to be honest with you, I'm not going to play tricks with you with unit conversions. Okay, so like the most you might have to do is like feet to inches or feet to miles. Whoa, didn't mean to do that. Anyway, I really, you don't have to know this stuff too much, and I hope I'm going to get this right. I do teach this. There are 100 centimeters, right, in 1 meter, and then aren't there 1,000 meters in 1 kilometer? I think. So that's 1, 2, 3, 4, 5. So my R is 0.00033 kilometers. That makes sense. That should be pretty small. So I'm going to actually put that in for this guy right here. So right here, I'm going to put in 0.00033 kilometers times my angular speed, because that's what I want to know. What is this angular speed in revolutions per hour? I'm going to have some work to do with that revolutions per hour, but for right now, I'm just going to leave it like this. I'm going to divide everything by the 0.00033 kilometers. I can think of that as multiplying by 1 over it. I'm doing 1 over it so you can see that my kilometers cancel. So if I take that 40.616 divided by 0.00033, right? Oh man, I get 1,2,3,0,7,8.7879. Now notice my units cancel per hour. So remember, that's radians. Radians are unitless, okay? So that's radians per hour. So I know I have about 123,078 radians per hour. Okay, and now what do they want? They want revolutions per hour. So again, I'm going to use that fact that 1 revolution is 2 pi radians, except I'm putting the revolution on top and the radians on bottom because I want basically my radians to cancel out. So I'm going to take that number, I'm going to divide, make sure you put parentheses if you don't have a fraction key, and it looks like to me I get about 19,588.59748 revolutions per hour, which seems like it should be a pretty high number, right? We're not talking per minute per second, we're talking per hour. Okay, I hope that one helps a little bit. Again, you're going to have different numbers. If you have the same numbers, don't just enter the answer. Make sure you understand, you know, how to get it. Okay, let's keep going because I'm having fun. I'm enjoying this. Okay, let's look at this one. A rear wheel of a tractor has a 21-inch radius. Find the angle in radians through which a wheel rotates in 13 seconds if the tractor is traveling at a speed of 25 miles per hour. All right, let me clear this out. All right, guys, so this one's a little bit trickier, but we're going to be able to do this. So let's see what we have. So I think I already said this. I had to pause for a minute. Sorry, someone came to my office. 21-inch radius. Find the angle through which the wheel rotates in 13 seconds if the tractor is traveling at a speed of 25 miles per hour. So again, I'm just going to kind of start with, this is number 9, what I know, right? I know that V equals R times omega. And it looks that 25 miles per hour is going to be a linear speed, right? Because it's miles, that's a distance, over hour, which is a time. But it's not in the right format. I don't want miles per hour. I have seconds that we're talking about here, and I have inches. So my first step is going to be to get this linear speed, which is miles per hour, and I want to put it into inches per second. Okay, so this is going to be a little much, but I think we'll be able to handle it. So let's get the miles to inches first. So I know that there are 5,280 feet in 1 mile. And then I know a lot of things, sometimes not things that are useful, but I know there are 12 inches in 1 foot. Okay, so my feet are going to cancel, my miles are going to cancel. And now let's get my hours. So I know in 1 hour, there are 60 minutes, and I know in 1 minute there are 60 seconds. Okay. Okay, so let's see what we have. So my minutes are going to cancel, my hours are going to cancel. This is all good stuff. I'm going to have inches per second. So let's multiply this all out. So 25 times 5280 times 12. And then divided by 60 and divided by 60 again. Thank goodness for dividing by those 60s. So we actually get 440 inches per second. And again, this is a linear speed because that's just a straight distance. It's not an angle. It's a distance divided by time. So here's what I know. I know that I have 440 inches per second is going to equal that 21-inch radius, right, times my omega. And here's what I want. So it wants to know the angle through which the wheel rotates in 13 seconds. So you guys, if you can find your angular speed, what that's going to give you is it's going to give you radians per second. And so then I can just multiply by 13 to see how many radians it's actually gone through, right? If I have the number of radians per second and I want to know how many radians in 13 seconds, I'm just going to multiply by 13. So divide by 21. Or multiply by 1 over 21 if you want to see that your inches cancel. So 440 divided by 21 is about 28.95. So my angular speed, right, how many radians I go through in 1 second then is 20.95 radians per second. So how many radians in 13 seconds? We'll take that 20.95 per second and multiply by 13 seconds. Over 1. And do you see you're going to be left with radians? Okay, so in mine I get about 272.38 radians will be traveled in 13 seconds. That one's a little tricky. If you have questions on that, hit that Ask My Instructor button, you guys. I'm happy to send you like your own personal video, or I can write up solutions and send it to you as a picture or something. We can work it out. And I apologize if I had known Mrs. Ware was going to be gone today. I totally would have come to your class today and switched my office hours around. But I didn't quite know that. So, all right. So let's look at this one. Let me clear this out. So the blade on a typical table saw rotates at 3,500 revolutions per minute. Calculate the linear velocity in miles per hour of one of the teeth at the edge of the 13-inch diameter blade. Okay, so let's set this one up. So what do we know? The blade rotates at 3,500 revolutions per minute. So that's omega, right? So we have 3,500 revolutions per 1 minute. And what do I know? I want to get to miles per hour. So let's go ahead and change the minutes to hours. But what else do I know? I know that there are 2 pi radians in 1 revolution. And then minutes, there are 60 minutes in 1 hour, right? Wow, this is going to be a large number. Well, I guess that would make sense if we're dealing with the table saw. I mean, I haven't really worked with the table saw very much, but you know, whatever. So this is, I'll just leave this at 420,000 pi per hour. Okay, so calculate the linear velocity, and all I need is v equals r times omega in that case, which my r in this case is 13 inches. So that'd be 13 inches, right, times 420,000 pi per hour. And so you'll notice we'll get inches per hour. Oh, but they want it in miles per hour. Okay, so let's see what we get here. So that times 13. I'm gonna leave this in terms of pi. 6, 1, 2, 3, 4 pi inches per hour. And now let's do a little bit of conversion. Thank goodness, because that's a large number. 4 pi inches per hour. And now you kind of know what the gist is. There's 1 foot in 12 inches. And there in 1 mile, there's 5,280 feet. So I'm just going to take that answer, divide it by 5280, then divide it by 12. That's a little nicer. That's fast. I would assume that would be true. I got about, well, 270.72. Okay, miles per hour. All right, you guys, one more. Let's look at this last one. So this one is going to be pretty similar, but let's kind of, I'll set this up for you. I want to make sure you guys are understanding this well. So we have a Ferris wheel was built for an exposition. Well, I'm a math teacher, guys. Anyway, it held 2,100 people, had a diameter of 246 feet, and took 40 minutes to make 1 revolution. So the 2,100 people doesn't matter. Okay, find the linear velocity in feet per second for a person riding this wheel. So this is the last one. So let's look at, we know my diameter. Oh no, you guys. Hey, back on this one, I just realized this. This was a 13-inch diameter. So you needed to, we should have taken that 13 and divided it in 2. I apologize. I wonder if it'll let me go back and do that. Oh, look at that. Nice. So right here, I apologize. This should be 6.5. 6.5 inches should be the radius. You probably saw that. Sorry about that. You probably saw that. Anyway, easy to do. Okay, so 246 feet. So what do we know the radius is? 246. I can do that in my head. Is 123 feet, right? Divide that by 2. And it took 40 minutes to make 1 revolution. So let's look at that again. So my angular speed, I have 1 revolution in 40 minutes. Okay. Find the linear velocity in feet per second for a person riding this wheel. So let's go feet per second. So I'm going to do 2 pi per 1 revolution. And then I know I want seconds. So I'm going to do in 1 minute. There's 60 seconds. Might as well do some of these conversions right now. So 2 times pi divided by 40 divided by 60. So it looks like our linear or angular speed is 0.002617994. You know, I go out a little further because I know I'm going to be using this in my, you know, next. So my velocity then, remember we want feet per second, so I don't need to change my R. So that's 123 feet times this guy. You can't do this, but I can. Second. So times that by 123, and I got 0.322 feet per second. I need to make sure that's right. Does that sound about right? Yeah, I would guess so. I mean, we probably wouldn't want to go too much faster. It is a Ferris wheel with 2,100 people on it. Rounded to the nearest tenth, so 0.3. Let's see if that's right. Nice work, Sarah. Good. All right, you guys. So I did all the 6 through 11 problems. I really hope that helps. I'm sorry if my lecture wasn't clear enough or I didn't do enough examples. I apologize for that. I'll also be sending an email. I think we'll postpone maybe the test maybe until Thursday. I don't know. I need some feedback probably on that. Anyway, please let me know if you have questions. Feel free to hit that Ask My Instructor button or send me a message on Canvas.